what I would do immediately, I would change it into this, because it's easier to find. I know I will have to find the first and the second derivatives. It's much easier to find the first and much easier immediately to find the second. Bring down -1, so I have 2 x plus 3 to -2 times the inner function prime, which is 1. So I already have 2 over x plus 3 squared. When I differentiate, I get -4 x plus 3 to -3 times the inner function prime, which is 1. So then I have -4 over x plus 3 to the third. So I accomplished a lot. All I have to do now is put it in the table and be able to graph it. And that's it. So anyone can tell us the domain of this function?
Is it everything except for -3?
Yes, thank you very much. So whatever you put here, it's up to you. I just put 3 bars and then fill it in, whatever. So 0. When I plug in 0, I get -2/3. This is type 1. So I know it's type 2. So I know the horizontal asymptote is 0. I know that x equals -3 is a vertical asymptote. It's type 2. How do I know? It has a higher degree in the denominator than the numerator. So I don't have to calculate anything. Good. So I look at the, so I need the limits here and here. -3.1, negative over negative. -2.9, negative over positive. That's it. I'm done with the function. I also have the first derivative, which I see it's always positive. No critical numbers. Now I check my table. If these 2 rows do not go well, increasing, decreasing, whatever, then I know I have an error. Okay, so let's take a look. From 0 to infinity, yes. From -1 to -2/3, yes. From -2/3 to 0, yes, according to this. Now, according to this, careful, to the left of -3, like -10, negative with negative. So this is positive. So the function has to open up. But on the other side, when I plug in 0, I get negative. So the function has to open down. That's all you need. And then when you graph, you have a vertical asymptote at -3. X equals -3. A horizontal asymptote, which is an overkill because it's already there. It's the x-axis. All you have to do now is follow the table. And you're done. On the left-hand side of the vertical asymptote, from 0 to infinity, opening up. Done. On the other side, it crosses at 0, -2/3, right here. And it's coming from -infinity, opening down, crossing the y-axis, going to approaching 0. That's it. That's your graph. So you only have 14 questions for 2 hours, which is way more than you need. And the only question that has 1 point will be the extra credit. Everything else has more points. I selected 1. I gave it so little points, so it's extra credit. The system does not allow, normally in other systems I put 0. But in Pearson, I cannot put 0 in. So the minimum is 1 point. So it's the only problem that is worth 1 point, and it will be the extra credit for 10 points. And I will grade it separately because the system will say, if you do it correctly, 1 out of 1. Any questions? Any questions? Let's look at a graphing a polynomial function. Any questions on this problem? It's really very straightforward. If you determine the first derivative correctly, the second derivative correctly, you study their sign, you should have zero difficulty here. And please remember, type 1, type 2, type 3. We did not expand on this. So basically, we're focusing on type 1 and type 2. I don't think that this is a major topic. I did not show you an example. If you want me to, after the test or before the test or whenever, we can work on a slant asymptote situation. So right now I wanted to go to graphing a polynomial function. Like for example, f of x, 2x to the third minus 6x. So let's work on this. Again, the same thing. I determine the first derivative immediately and the second derivative immediately. Can anyone give us the first and the second derivatives?
The first derivative would be 6x squared.
Sorry about that. 6x squared minus
6.
Very good. So when I determine f prime of x or solve or f prime of x equals undefined, I know this is not the case because it's polynomial. When I solve the equation, I have, of course, x squared minus 1 equals 0 because I already divided. I didn't factor. Let me write it so you see it like this, and then you divide by 6. So it's x squared equals 1. Remember, when we take the square root, it's quadratic. We have to get plus or minus 1. Perfect. Thank you, Haley. Now, can anyone give us the second derivative?
Just 12x?
Yes. Don't forget the table. And all real numbers because it is polynomial. So the second derivative is 0 when x is 0. So what we have to put in the table, -1, 0, and 1. These are the critical numbers. And I have to study the sign. When I plug in 0, this is negative. When I plug in left and right, it's positive. The second derivative is 0 at 0. The sign to the left is negative, so opening downward. To the right will be opening upward. Good. So now I have to determine when x is 0, I have 0. When x is -1, I have -2 plus 6, which is 4. When it's 1 is -4. And the limits. At -infinity will be -infinity. How do I know? So at -infinity, this is the strongest. This means nothing. At infinities only. So this is negative and this will be positive. That's all I need. I'm done. Now I have to make sure that these two rows work well together. And then I can check with the third row. If they don't work well together, then I'll say, uh-oh, something is not right. So from -infinity to 4, yes, it's increasing. That's correct. And from 4 to 0, yes, that's correct. So this is a relative mass. And it makes sense. Look at the shape according to the second derivative. This is an inflection point because the second derivative changes sign. So this is an IP. This is decreasing, yes. This is increasing, yes. So this is a relative min, and it makes sense. Look at the shape given by the second derivative. And this is done. I'm done. 3 minutes. Do you have to finish it in 3 minutes? No. But don't waste half an hour on it. I don't want you to waste half an hour on any of the problems. Please. Okay. So I'm going to graph -1, 4, 0, 0, and 1, 4. From what I forgot, and I cannot forget that, is the x and y intercept. The y-intercept we do have, but the x-intercepts, let's work on the calculator. We cannot do without those. So let me share my screen. Where are you guys? Okay. Good. So we put in the graphing calculator. In apps directly, don't spend too much time on this. It's a polynomial root finder, but it's degree 3. Careful. And careful how you enter the coefficients. We have 2. But the coefficient of x squared is gone. It doesn't exist. The coefficient of x is -6. And the free term is gone. Okay? So we have 3 coefficients, 3 solutions. We knew about 0, but we have 1.7 and -1.7. So I need those in the table. So -1.7, 0 here, and 1.7 and 0 here. I need those. From -infinity to -1.7, going up to a relative max, opening down. Increasing from -infinity, crossing the x-axis, getting to the relative max. Continues to decrease till this point, where it changes concavity. So it opened down, but now it all of a sudden opens up. So opening up to -1 to 1. Sorry. I messed up. It's right here. Good. So from -infinity, crossing the x-axis, reaching the maximum, coming down to the inflection point. At this point, it changes concavity, opening upward, getting to, I didn't want to change the color. I don't know why I changed the color. Okay, so opening upward, reaching a relative minimum at -1, 4, crossing again at 1.73 and going to positive infinity. And this is the function f of x, 2x cubed minus 6x. Did I write the function on that? On paper, I always have to write the function. So this is f of x, -2 over x plus 3. Any questions? Any questions? Okay, the next topic after graphing, differentiation, just finding derivatives. So which topic did we get to after graphing? 6, derivatives. Okay. So let's say g of x equals natural log of 3x, everything to the 4th power. That's an example. let's say another one, f of x equals x squared plus 2x minus 3 times e to 2x plus 4. And another one, another g of x, let's say 3x to the third minus 4x e to 4x. Okay. Good. So the first one, g prime of x, bring down 4, subtract 1 from the power, multiply by the inner function prime, 1 over 3x, times the inner function prime, which is 3. 4, natural log to 4 minus 1, natural log prime of 3x, times the inner function prime, which is 3. Now you can simplify and condense into 4 natural log 3x raised to the third power, everything over x. These problems should take under a minute. Do you have to? No, I'm just saying. The next one is a product. I have to differentiate the first function first, 2x plus 2 times e to 2x plus 4, plus I copy the first function I meant to say, times the second one prime, which is e to 2x plus 4 times the inner function prime, which is 2. And you can leave it as is. It's nice if you just factor out e to 2x plus 4 and simplify a little bit. So you could continue here, writing e to 2x plus 4. Then I have 2x plus 2, and then I have to distribute 2 in here. 2x squared plus 4x minus 6. I don't want this to confuse you here. And rearrange that in a descending order. So 2x squared plus 6x minus 4 e to 2x plus 4. The third one, I'm going to copy it here again. 3x to the third minus 4x e to 4x. Any questions on the previous two? And on this one, g prime of x, this is very simple. 9x squared minus 4. And now be careful, this is a product. The first function prime is 1. Plus x times e to the 4x times the inner function prime. And now you can distribute. So I have 9x squared minus 4e to 4x minus 16x e to 4x, and you can leave it as is. And one more topic that I was thinking about is domain and graphing. This is algebra, basically. There is no calculus here. Log functions and exponential functions. This is from chapter 2. So for example, if I have, let's say, f of x equals natural log of 4x minus 3, what if I'm asked to find the domain? What will be the inequality that I have to write and solve to find the domain?
Isn't it 4x minus 3 has to be greater than 0?
Absolutely. because the graph of the natural log function, base function, natural log x, is this, which requires x to be greater than 0. So log has to be applied to a quantity that is greater than 0, never even equal to 0. I move 3 divided by 4. So then the domain is 3/4 infinity, not with the bracket, but with the parenthesis. If you review the problems we did in class, if you look at those simple examples with the marginal cost, marginal revenue that we did in class, related rates that we did in class, the linearization, I can't think of anything else, really. Maximizing volume. Closed interval, finding max min on the closed interval, graphing, that's all we studied, these applications.